In this tutorial, we're going to talk about the producer-consumer problem. So this is a classical problem for synchronization, and is described in the little book of Semaphores, which is a very good book that has a lot of classical problems such as this, and it also has some of the solutions. So there is also the barrier problem and all kinds of theoretical synchronization problems. Okay, so let's start. So in order to implement this, first we need a semaphore. So let's write a semaphore class. Okay. A semaphore is basically an integer. So it's an integer that multiple threads can increment and decrement in a thread-safe way. However, it cannot be decremented to a value smaller than 0. So if a thread attempts to decrement a semaphore whose value is 0, then it's going to get blocked there, and it's going to have to wait there until another thread increments that semaphore. So essentially, semaphore, let me try to type here. Okay. Is a very useful concept, and you can use it to implement other synchronization mechanisms, such as mutexes. A mutex is basically a semaphore whose initial value is 1, so it only allows one thread to pass through into the critical section. Okay, so let's say class semaphore. Okay, so first what we're going to need is a counter, and then we need a semaphore. So we're going to be using boost. So let me just include some stuff here. So we need a condition variable, and we need a mutex. Okay. So we're going to have a mutex and variable. Okay, so these are our private members. Okay, so now for our public members, we need a constructor that's going to take an initial count as an argument. It's basically going to set the m count to the initial count. Okay, so now we need a signal function. So this is going to be our increment function. So we need to lock the mutex. We need to increment our counter, and we need to notify the condition variable. Okay, so now we need a wait function, which is essentially our decrement function. So once again, we need to lock a mutex. And then here is going to be our loop where threads are going to wait until the counter is 0. Sorry, if the counter is 0, so if you try to decrement, then the threads are going to sit here on this loop. And wait. Okay, so now, assuming that we get past this loop, then we can decrement the counter. Okay, so that's our semaphore class. And now we need to write a so the producer and consumer are going to be workers. So we need a worker class that defines some common mechanisms, such as starting the thread, waiting for the thread, etc. And in our solution we have these semaphores. So we have items, we have spaces. These are our two semaphores, and then we have a mutex. So these exist in both the producer and the consumer. So in the worker class, we're going to define pointers for these. So these are going to be shared. Okay. So let's write a class called worker. Okay, so once again we're going to be using boost. So we need to include boost thread, and we need to include a mutex. Boost thread mutex. And we also need to include the semaphore class that we just wrote. Okay, so this is going to be a templated function, because essentially this buffer here, so we don't know what type the items in this buffer are. So these could be integers, or these could be some sort of a class. So we need to have a templated worker class. Type T, and then we need another type for the function. So essentially the producer and consumer are going to be running a different function. So this type is going to be different for those two derived classes. Okay, so class worker. Okay, so the private members are going to be so we need a semaphore called items and spaces. So semaphore and items and semaphore and spaces. And also we need a mutex and mutex. And also we need a buffer. So let's use a queue. Oh, what do they call it? M buffer. Okay, M buffer. Okay, and also we need a thread, because this loop is going to be running in a separate thread. Okay, and also we need a function that's called mwork. So this function is going to process the item. So in our two classes here, consumer and producer, we have this function here, and then also we have this other one here, wait for event. So in this parent class, essentially this function is going to be one of these. But in our derived classes, we're going to define what these mean. Okay. So now we need some accessor functions. So we need a Semaphore get items, which is going to return m items, and then also we need a semaphore to get the spaces. And we need a function to get the mutex. And to get the buffer. Okay, so these are our accessor functions that we're going to be calling from the derived classes. And then also we need a virtual function called run. So this function is going to contain essentially this loop here and this loop here. So it's virtual because it's different for the two derived classes. Okay, and also we need a constructor. Okay, so this is going to be Semaphore p items, Semaphore spaces, mutex p mutex, or buffer. And the work function. Okay, so let's initialize these. I think that's it. Okay. So we also need a start function and a wait function. So the start function is going to is going to start a new thread. Okay, also here we need another initialization, which is going to initialize the thread to null. So essentially, the start function we can only call once. If we try to call it a second time, then it's basically not going to do anything because thread is already going to be a not null value. So we need to bind it to our virtual run function and pass it the parameter, which is our work function. So essentially this is going to be our parameter. See, so here the parameter type is f, so that's what we have to pass. Okay. And then in our wait function, we have to wait for the thread. Okay, so that's basically our worker function. So now let's implement a producer. Okay. Okay, so I can see what we have here. So we'll start with our header cards. Once again, we're using boost. And we need to include deck, and we need to include, no, here. Yeah, of course I need to include a deck here as well. Okay, so we need to include a thread, or maybe not. Maybe actually I don't need any of that because it's already encapsulated here. So yeah, I definitely need a. No, I do need a thread, or sorry, a mutex and a semaphore. Okay, because they're going to be in the constructor parameters. Boost thread. Okay, and then this is going to be a templated function once again. But we only need to know the type of the items in our buffer. So the function type is going to be t star, and then we're not going to pass any parameters. Okay, so what this means here is that the function is going to just produce items of type t star. And okay, so let me just give an example later. Okay, so we need some private members, which is going to be the definition for our run function. Sorry, t. So this is going to be our function name produce. Okay, so now here, while true, so here basically we're going to implement this producer. So we're going to get our item and then push the item into the buffer and make sure that all the semaphores are incremented and decremented as necessary, and also make sure that the buffer is protected by a critical section here. Okay, so now our item is going to be produced, and then let's see, what are our accessor functions? Okay, so we need to wait on spaces semaphore. So it's going to be this .get spaces wait, and then we need to walk the mutex. So this get mutex. Okay, so let's do a unique lock. Okay, so here. So a unique lock, basically it unlocks once you exit this block. So once the code reaches this close parentheses, then the unique lock unlocks. Okay, so get buffer, we're going to push back the item. Okay, and now we need to signal our items semaphore. Okay, so that should work. And for our public functions, we need a constructor. So we need a semaphore. Spaces and mutex. Into our buffer. And here we need to specify our function. Okay. And then we're going to initialize our parent class worker. With these parameters, items, spaces, p mutex, p buffer, and produce. Okay, so this is our producer class. It's pretty simple. What we did was we defined this virtual function and we just mapped all these things from the constructor into the appropriate parent class constructor parameters. Okay, so now let's write a consumer class. don't want to see this. Okay, but here I'm going to do worker, or sorry, consumer .h. And it's very similar here. So first we start with our header guards. And diff, sorry. Okay, and then we include some stuff, so we need to include a deck. We need to include some boost stuff. We need to include text. And include a semaphore. And include a worker, which I honestly don't remember if I included a worker in our producer class, so let me check. Producer H. Yeah, I didn't. Okay. Actually, we don't need that here. We just need worker. Okay, I think that's correct. Okay. So now, namespace boost. Oh yeah, the deck is actually a different namespace. It's the standard namespace, so we need to make sure that we're using that here. Here as well. And actually here as well. Okay, so this is once again going to be a templated class. And it's going to derive from worker. And our function type is going to be void. And it's going to take t pointer as a parameter. Okay, so the consumer, basically we're going to consume the item. So I know here it's a little bit different, but in our case we're just going to pass the event into the as a parameter to this consume function. Okay. Check, forgot a semicolon. Okay, and here once again we're going to be using the same format. So we need to define our run function. And then here's our consume function type. Okay, so once again, we need to have a while loop that is going to do this stuff here. So first we need to wait on the items semaphore. So this get items wait, and then we're going to use another scoped unique lock here. And okay, so we need to check if the buffer is empty. So if this get buffer empty equals false, then we're going to pop the we're going to get the front element from the deck. So okay, so item is going to be get buffer and get data. Buffer front. Okay, so we need item here. Okay, so now we need to signal the get spaces signal. Okay, and now if our item is not null, then we're going to consume it. Okay, so basically that's our run function for the consumer, and now we just need a constructor. So let me just copy this guy here, because I don't want to retype all that stuff. Okay, and then change it to consumer, and here we need to change the type. And here, I need to change the type again. Okay, so basically that should work. So these are our two classes, producer and consumer. So now let's write a little test. CPP file. So let's save all these and then write test.cpp. So we need to include some printout header file, and we need to include producer and consumer. Okay, so now using namespace boost and using namespace standard. Okay, so now let's write a main function, and we need to declare a queue. Let's just say we have integers. So queue, yeah, let's just call it queue or something. Okay, new deck int. Okay, and then we need to specify the buffer size. So let's say buffer size is 1000. So that's going to be the maximum number of integers that we can store before one of the semaphores starts blocking. So I think it's the let me check. So we have items and we have spaces, and Yeah, so let's see. Spaces is going to be initialized to our buffer size, and items is going to be initialized to 0. So once we have incremented the spaces semaphore, or sorry, decremented the spaces semaphore this many times, then it's going to start blocking. So we can't put more than 1,000 elements into that. Okay. So let me initialize these things here. Okay, so mutex. M is going to be just a new mutex. And then semaphore. Items. It's going to be new semaphore with initial value 0, and semaphore spaces is going to be a new semaphore with initial value buffer size. Okay, so now we need to make some producers. Oh, I should probably include a vector here. Vector. Okay, so now let's make some producers. Producer. So let's have 2 producers. Okay, so let me check what the constructor is. Producer. So we need a semaphore here for items. And we need spaces, and we need our mutex M, and we need our buffer, which is Q, and also we need a function, which we haven't declared yet, but let's just call it produce. Okay, so now let's do the same thing here, and make some consumers. Okay, so these are the same, and the only difference is here. So we need to declare these 2 functions, and also we need to start our producers and consumers. So for entire I less than producer size, and we're going to start the producers, and then we need to start the consumers. Okay, and then check here, worker. So here are our functions. So we can start a worker, and then we can also wait on the worker. So we need to wait on these so they don't. So basically they don't let the main thread exit. Okay, so here let's do wait, and then wait, and then finally return 0. Okay, so now we need to declare our two functions, consume, or let's do produce first. So produce is going to return a integer pointer, and it's going to be just a new random integer, and then consume is going to print out the integer. And of course we should delete the integer so we don't have a memory leak. Okay, so let's see if that compiles. Oh, first of course we need to make file. So make file. So here let's do all G++, C++ 11, and we're going to optimize it. Test CCP, and output name is going to be producer consumer, and we need to use boost threads and boost system. So fingers crossed, let's see if that compiles. Oh, okay. H, do we not have header guards? Oh, that's right. Okay. Okay, so almost perfect. I just mistyped something. Okay. So now let's run our producer consumer, and we see that it's printing out a whole bunch of random numbers. Okay, so now let's look in our test CPP file, and let's maybe make some more of these. So 300 and 300. Okay, so now we have 300 producers and 300 consumers, printing out, or generating random numbers and then printing them out. And then here we can see that the utilization is pretty low because basically each thread is doing very little work. So if you want to have a higher utilization, then you probably want to give each thread a lot of work to do, instead of just printing out one integer. But yeah, basically there you go. And we see that the RAM isn't increasing, so that's a good sign. That means that we didn't have a memory leak somewhere, or maybe it was increasing a little bit. Okay. Yeah, so it went down. Alright, so this is of course not a production-ready implementation. So for that you would need to have a termination mechanism. So right now, the producer and consumer, they just keep running forever because we have a infinite while loop. But realistically, we'll want to have a termination condition, and upon termination, we would also want to clean up our threads and our queue and semaphores and mutex. So yeah, definitely for production ready implementation, you would want to implement some cleanup mechanisms. Okay, but basically that's it. So definitely have a look at this little book of semaphores. It has a lot of good stuff in there. So I guess the next problem is readers, writers problem, which is also a good problem. But I'm guessing that has to do with disk I/O. Okay, well, that's the end of the tutorial.